All right, this is the full hour, and we are back with the Virtual Jug 24, the 24-hour Java conference, online only, organized by Virtual Jug, which is an online only Java user group. And the next session that we're going to have here is the Diabolical Developer's Guide to Java and JVM Performance Tuning by Martin. And before we dive into the session, and before we welcome our participants for this hour, I just want to say that this time slot in this session was sponsored by the IBM, and we're going to have the Czech Jug and Malaga Jug with us. They all joined. We are all ready. So let's just have a couple of minutes for the organizational matters. VJUG 24 is a long conference, so it wouldn't be possible to do something like that without the sponsors. So for this particular session, the sponsor is IBM, and they're doing a lot of stuff for OpenJDK, for Java ecosystem, and they have multiple initiatives going on that are very interesting. So if you heard of IBM like 10 years ago, and you have this a little bit maybe outdated point of view on what they do, check out the links on the slide. They have the Open Liberty, the small and fast application server. They support the micro-profile initiative, which is the slimmed down Java EE, a part of Java EE. It's a spec, and you can deliver rapid innovation across multiple runtime implementations. So specifically created for microservices. And of course, they have the OpenJ9, recently open sourced the JVM implementation, and with low memory footprint, with fast startup time. Just 2 sessions ago, we had a talk by IBM people, and they dived into some of those initiatives, and it was very interesting. So be sure to check out the links. Be sure to keep up to date with what they're doing. We are really grateful to them for supporting VJUG 24. As well, we are really grateful. Massive thanks to Zero Turnaround, which is the main sponsor for Virtual Jug itself, the producer of developers tools for Java developers. Check those out. Zero Turnaround would be happy, and the Virtual Jug would be happy as well. A moment for the organizational message. If you are just joining us, you are welcome to go to vjug24.com, even if you're watching this just on YouTube, where the video will end up eventually. Just go to vjug24.com. There is a button to join the Slack team, and on that Slack team, you can jump on the live session channel where you can participate in the discussion of the contents of the session, ask questions to the speakers, and communicate with other people watching the sessions live. It's a great resource. There is active discussions for 10 hours now, or 11 hours. If you are using social media, the official hashtag for the conference is #VJUG24, so be sure to share those. And if you're just joining and watching this either on the VJUG24 page or on YouTube, be sure to increase the video quality up to HD. That helps tremendously with the readability of the slides, and you will have much better experience in watching the sessions live. With that said and done, let me stop the screen sharing and let me try to introduce the participants of this session. So first, I think we have the Malaga Jug. Jorge, are you there? Excellent. We can see you.
Hello. Hello, Lee from Malaga. How are you doing, everybody?
Yeah. Excellent. It's great to see you. I'm a bit jealous. It was the forecast today for Tartu, Estonia was that it's going to be snowing. So I'm a little bit envious of people in warmer climates. So be sure to enjoy the session, and you can go out in the sun later week, Friday, for example. And I think we have another Jug joined, the Czech Jug. Andre, we have a couple of people, and we see people watching. So if you can make some noise for the VJUG24. Yeah, we can see you. We don't hear you, but we can see you. Hello. If I'm correct, this is Prague, a lovely city. So welcome. I hope you enjoyed the session. And without further ado, let me introduce Martin, our hero and the presenter for the next session. Martin is an excellent part of the Java community, part of the representative of the London Java community on the JCP Executive Committee, the receiver of a recent Adopt a GSR Adopt OpenJDK award by JCP as well. He does a lot of stuff for the London Java community, and he knows everybody, and everybody knows him. And if you have any questions about Java or JVM, even if he cannot answer himself, he certainly knows people he can point towards, and they will explain everything. So without you, Martin, the Java community would not be the same. So
thank you. Very kind.
That's just true. So without further ado, the stage is yours. The Diabolical Developer's Guide to JVM, Java JVM Performance Tuning, and take it from here.
Cool. Thank you very much. So thanks everyone for joining. It's been a pretty awesome marathon in the VJUG 24 so far. So I'm going to try and share my screen here. Let's see if good old Google Hangouts technology actually works.
Yep, we can see your screen, and we can see your
slides. Can you see a slide?
We
Fantastic. Do. Okay, so right, so I'll get started. So this is my very quick overview guide to the sort of things you can do at 3 o'clock in the morning, you up, and is screaming down the phone at you because the website is performing slowly, or your data grid is performing slowly, or some piece of code that you wrote or some piece of code that you manage is not performing up to expectations. The traditional diabolical developer style. So I'm fairly informal. I will try for a change not to swear live on podcast. And you can't see me drinking a beer, but I assure you that I have a lovely Japanese Kirin. Help me get through this. So my backgrounds, thanks for introducing me earlier. So I'm the CEO at a company called JClarity. We do Java and JVM performance tuning. We specialize this in it for a number of years, and we have services around that stuff. I've seen hundreds of poorly performing applications. This talk specifically will focus primarily on the server side, so the things you will look at for the Java and the JVM and Linux and things like that. And I'll throw a few cloud references in there as well, because I know everybody wants to be in the cloud. So to begin with, what on earth is performance anyway? We define it at JClarity as the efficiency of how something reacts to or fulfills its purpose. So does that web page respond in the time frame that you expect it to? So does the login page respond in 500 milliseconds? 100 people log on, that sort of thing. And the key thing really is it's about the time it takes to complete a particular unit of work, resources that unit of work takes. So how much CPU, how much memory, how much network, how much hard disk when a login request happens, when 100 login requests happen, that sort of thing. And of course, it's very, very important to make sure that you have proper user-defined requirements or system-defined requirements. So what are the throughput goals? Something along the lines of 100 messages per second through your system. The latency goals, so how fast you want requests typically to be able to respond. So does that search page respond in a second if you give it a particular query? And of course, very importantly, our resource goals. So if your throughput and latency goals, but sometimes that means you have to buy really expensive hardware or have a very large JVM heap or have lots and lots of cores on your CPU. And is that really affordable? So here are the 8 broad topics I'm going to cover. The first 4 sections are the really, really important ones. So this is where I'll go into some of the methodology and the, I'll call it a loose scientific methodology that we have around how we do performance tuning and performance diagnosis. Then the following 4 sections are some just-in-time advice or tools that you can use or techniques that you can use, which will help you with Java and Linux and other systems as they are today. 4 sections should not ever, and I do want to reiterate this, should not as performance tuning advice for your application. Okay. Every application is unique. Business logic has different resources allocated to it, has different traffic patterns. And so please don't take any of the tuning advice, as it were, that I give in this talk, blindly apply to your applications. If we ever catch you doing this, kittens and puppies will probably die. The thing you want to think about, and quite often developers don't have to think about this too much, all the way back to thinking about we're in a resource-constrained world. So the actual physical boxes that your software is running on only have so much capacity with regards to CPU, write capability, so on and so forth. And of course, it has been made much, much worse. So many of you are now running on some sort of virtualized environment, whether that be AWS or VMware or some other sort of hypervisor. And then on top of that, some of you are now in the brave new world of containers. So you might be running Docker in particular, which again is giving you a subset, as it were, of the actual physical resources that that machine has. The key, and this is one of the things you should probably write down at this point, is make sure you find out what resources you are actually running on. And that means both the physical resources that the host has, resources that are being allocated or being shown to your JVM. So again, if you're running on VMware, or if you're running on AWS, or if you're running on a container, see and is only given a certain amount of resources, and you really want to understand what those numbers are in order to do correct performance tuning. Don't know what these numbers are in your production systems, fantastic opportunity to go and talk to your system administrator or your operations person and really gain some knowledge from there, and hopefully strike up a bit of a shared communication and shared relationship. Of traditional IT shops that developers and operations are worlds apart and don't necessarily get on all that well. And that is what the DevOps movement is all about, is to bring those two worlds closer together. This is a good time for you to go and speak to those people. Furthermore, about knowing what your host actually has, you actually also want to know where your hosts are and where your hosts are in relation to each other. So most of the customers we talk to are actually often quite unaware of where their machines are hosted and which data centers they're sitting in. So I'll give you a small classic example. For those of you who know the continent Australia, it is about 4 or 5 time zones wide. It's a very wide country. And one of our customers was doing quite a bit of log4j logging. Why it was taking so long, and they just couldn't understand why. And when we did a little bit of digging for them, we realized that their servers were in Sydney, which is on the east coast of Australia, and about 5 time zones away on the west coast of Australia in Perth is actually where their network storage drive was. And so they were sending their log4j messages up through a satellite link, back down through a satellite link. It was horribly slow and inefficient. And they'd been working this way for well over a year. It really is crucial for you to understand where your hosts are in relation to each other. Moving to cloud in particular, or moving to virtualized environments, is typically orders of magnitude worse in terms of performance and less stable in terms of reliability than your traditional well-run data center. So the uptime for cloud machines is typically nowhere near as good as your data centers, your internal data centers. Sharing the network with the cloud provider and all of the other customers of that cloud provider. A classic example of this was in the earlier days of Amazon, when Netflix was a heavy user of some of Amazon's structure. That during busy Netflix times, that customers on Amazon's bandwidth and resource consumption suffered quite significantly. So you really do have to be quite aware of your host, but what is also potentially happening on your neighbor's hosts. Next one. A key point about this virtualization topic, and I'll keep rabbiting on about this, is you cannot virtualize into more hardware. Time and time again, we see lots of people doing things like this. RAM on their physical machine, and they give it 4 virtual operating systems, 4 virtual environments, 4 virtual machines, as it were, and they give 4 gig of RAM to each of those virtual machines. Total of 16 gig of virtual memory to a physical host that only has 8 gig. And or the marketing of those virtual operating system suppliers, so VMware, etc., they've believed that they are so good at sharing the memory and sharing the resources that you can get away with it. The truth is you cannot. Please do some basic arithmetic and make sure that the number of CPUs you allocate, the amount of RAM you allocate, the amount of network activity and disk activity can actually map into what the underlying physical host has. This is super, super important. Tactic number 1, the number 1 thing you want to take away is you really want to know what your actual physical resources are. You also want to know what the virtualized or containerized resources are for your JVM. So go and find those numbers out. And then also make sure you actually understand where your hosts are, where your data centers are, customers, and in relation to any other hosts or services that you're relying on. Example is one customer we had servers running in Johannesburg in South Africa, relying on a advertising service out of Canada. So all of the ad traffic was being served from Canada, which is, as far as internet cabling, etc., is concerned. And so quite often their pages and their application was loading very slowly because they had just simply picked the right ad server to serve ads out of. So the next section is I'll get into what performance tuning actually is. And there's a whole bunch of broad categories, but it's so you really, when we go and hire people for JClarity, for example, we expect them to understand how the internals of the JVM works and how a modern CPU works. We expect a good knowledge of virtualization and containerization like Docker. And so you really need to more level than you probably have before if you're just a typical day-to-day Java developer. So you can dust off some of those old computer science books and hardware manuals and dig in. Great mailing list for this called Mechanical Sympathy, which is run by a guy called Martin Thompson. So I'd highly recommend looking that up. Then the next thing is you want to apply a methodology. Now, we have a methodology called the performance diagnostic model, which I'll cover in this talk. But what you'd want to avoid doing is just guessing. You don't want to sacrifice chickens or light black candles or go to Stack Overflow or read some outdated application server manual. They will all lead you down the wrong path. You really want to follow a proper scientific model and an approach and measure things correctly, changes based on those measurements and based on that data. Nice, like make minus XMS the same as minus XMX for garbage collection and heap sizing. That is what we call performance tuning by folklore. If you get told to do things like, oh, make sure you're using string builder instead of string buffer, or string buffer instead of string builder because this manual from Java 5 told us to, please don't listen to those lies either. You really have to investigate things through a proper methodology. Architecture, so I went through this before. You need to understand where your hosts are and where they are in relation to each other, what protocols you're using, what resources are involved. You need to understand the requirements. And when users tell you they just want things to be fast, that is not a real requirement. In terms of user requirements, typically come in the form of some sort of statistical curve. You're typically talking about percentiles. So, they want 1 second response time, for the 99th percentile. Right, so that's out of sort of 1,000 requests, 999 of them should come in under 1 second. You need to understand a little bit of math, and by math I mean you need to understand a little bit of statistics. Statistics or first-year university statistics is more than good enough. A little bit on that. Then doing some of the online courses in Coursera or Khan Academy will quite quickly get you there. There is, of course, tooling involved. We tend to use either JMeter or Gatling for our load testing. I'll go into those tools a little bit later. It's monitoring and alerting. And there are lots of free open source tools and Linux command line tools to get you that. And of course, because I work for JClarity, we suggest our analytics tools, but there's a whole bunch of others as well. So there's paid for products like our ones, AppDynamics, New Relic, and so forth. Some free ones out there, a little bit more basic, but you can get some quite useful information out of NetBeans, for example, or IntelliJ or Eclipse, those tools. And I'll actually show you some of those in this talk as well. Of performance tuning is to remove bottlenecks. And a bottleneck is what we define as something which is simply oversubscribed to a resource. Trying to write too much to a hard disk which can't keep up, too much memory, or the JVM is trying to use more memory than the operating system has. You're trying to utilize more threads than you've got in your thread pool, that sort of thing. So we're trying to remove those type of bottlenecks. So my second tactic is to please draw those logical and physical architecture diagrams. If you remember those good old days of using Microsoft Visio, or these days Google has got shared drawing tools, and there are plenty of shared sort of collaborative drawing tools. You don't have to use formal UML or any of that sort of nonsense. Just draw a pretty picture like a toddler would, and make sure your teammates can understand them. The next key thing is to make sure that you're measuring time at the various boundaries in your application properly. So you have to be really aware of time. Humans are notoriously bad at reporting time and measuring time in their heads. You have to watch out for things like time zones versus UTC. And you have to watch out for sampling rates. And some of the things you'll start to find when you look into this is that machines will lie to you. So the network time protocol can actually force machines to set their clocks back in time. Hardware clocks, so two different laptops will give you a different measurement for what they think 1,000 milliseconds are. Tell you what 1,000 milliseconds is. And each operating system, so Linux, Windows, Mac, they all actually have timing as well. So you have to be aware that when you're doing measurements, this is one of the reasons why you need a little bit of statistics. You have to take lots and lots of measurements and use some statistical analysis to get a sense of what is accurate or not by a significant mean and things like that. This is a very simple diagram of what a response time budget would look like for a typical client-server application. And you'll notice that at each entry and exit point, that is where you'll perform a measurement. So a measurement at the JavaScript layer in the client there at point 1, measurement at point 2, let's say in the servlet container, when that request arrives. Then again, a measurement at point 3, let's say at the JDBC driver, where a request goes out to the database. correspondingly, the measurements of those responses coming back. To very quickly narrow down where the slowdown is occurring. Is the slowdown occurring in the JavaScript, the database, or is it actually a network connectivity issue? So you really want to make sure that you've got those metrics in place. If you have to do a microservices or a peer-to-peer architecture, and you've got a diagram which looks like this, so most hosts point to other hosts, and it's very difficult to trace those distributed transactions. I have no good news for you. There are no industry standard tools at this stage to do what I would call distributed transaction tracing in a very nice manner. There is a new open tracing API and pseudo standard which is starting to come out. And that is something that we ourselves at JClarity will be looking to implement. But for now, I'm afraid this scenario is very tough to track. I'll ignore that. So tactic 3, make sure that you have the measurement at each entry and exit point into your architecture. That's absolutely crucial. If you don't know where the time is being spent, you have absolutely no hope of figuring out where the problem lies. On to the most important section. This is called the performance diagnostic model, designed by Kirk Pepperdine, who spoke the hour before me. He's JClarity CTO and world-renowned performance tuning expert. What this model here is telling you is that actors, whether that be humans or systems, push down onto your application. Your application, in turn, pushes down on the JVM, so it's threads, it invokes stack, it creates memory, it invokes a garbage collector, it asks the JVM to write to disk, to open sockets, all that sort of stuff. And asks the underlying, what we call the operating system / hardware layer, to perform all sorts of activities. Red layer, we also include the Docker container and the virtualization layer there as well. So basically the JVM is pushing down on your operating environment. There is one takeaway that you have. This slide is a slide you will want to copy. We will post this up on SlideShare, and VJug will also have a link to this, I'm sure. But this is a rough decision tree that we use as human consultants when we're looking to diagnose a problem. Stress, this is a very simplified model. In JClarity's tooling, for example, the machine learning algorithm has this looking much more like an incredibly complex spider web. But in terms of having a pseudo-scientific process to start with, the program will do you a lot of good. And what it's telling you, or what it's trying to guide you towards, is that it's asking you one simple question. What is your CPU doing? And when you think about it, you get a lot of hints as to what the CPU is doing and therefore what performance problems might be occurring. So if, for example, your CPU is busy doing lots of kernel or system activity, that means there's a lot of disk writing going on, or memories being shifted around, or lots of network sockets being open and closed, or perhaps there are lots of threads fighting over the scheduler, trying to get access to the CPU, that sort of activity. If the CPU is doing lots of what we call user time, that usually means that either the JVM is busy, usually garbage collection, or your application is busy doing a lot of work. So you've got some really hot loops or some really intense calculations, or your Java code is just doing an awful lot of work, which is keeping that CPU busy. If it is not busy, which is the bottom left-hand corner, then it usually means there's some sort of thread starvation issue going on. So some data effectively is not getting to your application, or your application isn't really doing any work. So why is that? Do you have deadlocked threads? Is the database not responding to you? Have you got a thread pool or something along those lines configured incorrectly? Are there no messages coming in from that third-party messaging system, or MQ series, or Apache Kafka or Spark, or those sorts of things? Are there messages coming through? with is the very simple command line tool, and we usually default to Linux here, called vmstat. You can give it an interval and how many times you want it to repeat to at least 6 sections, and this varies depending on what kernel version, etc. you're on. And basically what you're looking at is the right-hand column there, and the CPU column there showing the user column, system column, the idle column, and the wait column. And I'll ignore the wait column for now. Very quickly see from this particular output from vmstat that the idle column is in the high 90%. So this CPU is effectively idle. It's not doing any work. Now, if it's not doing any work and your users are complaining that your application is slow, that generally means that no work has arrived at your, or that your application is locked up somehow. So this means it's not garbage collection, because if it was garbage collection, then the user percentage would be much higher. It's not a case where you're fighting over the CPU, because your kernel time would be much higher, or your context switches would also be higher. It's not shifting memory around. It's not a problem with writing too much to hard disk or your hard disk churning. You can rule out all of those things immediately, right? This is clearly a case where either traffic's not coming into your application, or you've got probably some sort of deadlock or live lock going on. So the key question is what your CPU is doing, and it's really, really important to ask that question. And I'm actually going to go through now in the next 3 or 4 sections of that diagram I showed you, and some of the common tactical things you can do to then dive a little bit more deeply. On the first path, let's quickly flick back. So the first path, we're going to go up to this red circle at the top here, where the system time is dominating. So if the CPU is system or kernel, what we call kernel dominant, that means that you're either doing some heavy context switching, your virtualization or your containerization software is playing up. So things like Docker or your VMware is not allocating its resources correctly. Or you've got incredibly heavy network I/O going on. And you'll see below each of those options, I've listed some free command line tools or some other free tooling that you can use to have a very quick look at to what's going on with those. So if it's disk I/O, you can just run IOstat and see if there's lots of read or write happening. You can use things like the KVM command line tools, or you can just have a look at some of the Docker or Kubernetes command line tools. For network I/O, you can just use the netstat commands, or if you prefer a GUI tool, you can use the free tool called Wireshark with your network. So these Linux command line tools are the cheapest, fastest way to start. And as you get more familiarity with the methodology and the process, you can then sort of start to look at buying some of the more commercial tools or using some of the more complex open source tools. But in all seriousness, even though we sell a tool, we always recommend people just start with the basics, right? So start with some of these basic command line tools: vmstat, iostat, netstat. On this green path, where we're saying the CPU user time is high, then it can be one of two things. Either it's a JVM is busy, typically garbage collection. Application is busy. And because what we want to do is we want to rule out one of these paths as quickly as possible, the fastest thing you can do is actually look at the garbage collection, see if garbage collection is at fault. Because typically you can take a look at the garbage collection metrics and output and figure out in the matter of seconds whether it's the actual cause of the performance slowdown or not. So in order to do this, you need to turn on your GC logging. This slide are for Java 8 and below. New flags, which we will post after this talk. Flags I list there are the 3 flags that will create what we call a garbage collection log. There's less than 1% overhead on your JVM, so you can turn it on in production no problem at all. And interestingly enough, out of the VMs that we monitor and the hundreds of customers that we have, garbage collection is actually the #1 performance problem that we see for So we see it being around about 60 to 65% of the performance complaints that our customers have. And I can go into detail as to why that is, but we'll save that for a pub or a cafe conversation another day. You take the output from that GC log file and you put it into a tool. Now there's a couple of free tools out there like GC Viewer. I forget the other one. There's HP JMeter, not to be confused with the Apache JMeter. So there are a couple of free tools, and they will show you all very similar views to what jClarity Sensum does here. So here we have an example where we've seen that the user CPU time is dominant, so we know the CPU is busy, and we take a very quick look at this GC log, and we see immediately that it's doing full GCs all the time. All those little red crosses are all an individual back to back. So this JVM is just super, super busy, doing nothing but full GCs all the time. Instantly that it is actually garbage collection, which is the problem here. And for this particular customer, we would recommend, or user would recommend, double if not triple the size of your heap. Run this app again and see if that helps the problem. And the reason why I say that is because you can see that the full GCs are forming a flat horizontal line, which means that it is able to get to a steady state, but there's still not enough room for it to continue doing any real work. So the first thing it has to do is immediately throw another full GC and get back to that same steady state. So it's not actually, it's memory leak, even though it looks like one, because we can get back to that steady state. But we do want to just up the heap size here and see what we can do from there. A graph like this is a classic example of a memory leak. This graph is showing GC data over about 4 days, I think, possibly a little bit longer. And you can see that the red diamonds and red crosses are sort of incrementally going up to the right constantly. When we do a full GC, the heap is not returning back to a steady state, right? So there's definitely some objects that are leaking somewhere. And I would guess that in a few days' time that this JVM will crash with an out-of-memory error. As a side effect, each full GC longer and longer and longer. So again, this is a very classic example of throwing up a quick GC log and realizing in a few minutes that it's GC which is the problem here. I'll go into detail a little bit in future as to how you can go find what that memory leak is. If you see a graph which looks like this, which we call the sawtooth pattern, then you know you have a healthy JVM as far as GC is concerned, and therefore it's not a GC problem. Back to your diagram and say, aha, problem. So I now need to go do something along the lines of some execution profiling, go see what the issue actually is. Dimensions, when you have a memory leak, that there are some techniques you can to find the memory leak. What you want to do is grab the free tool Visual VM. You can just go to, I think, just search for Visual VMs on GitHub these days, I believe. You want to look for objects that have a high number of generations, and you have to tick the magic box, and that will then tell you what line of your source code these objects that are living in multiple generations, and that's usually your candidate for your memory leak. So here's an example using either NetBeans or Visual VM Memory Profiler. The Profiler tab, you will notice on the top right-hand side there is a checkbox there called Settings. Box you need to tick and open in order to make sure that you then check the Record Allocation Stack Trace checkbox so that you can tie back these long-lasting multi-generational objects to your actual source code. That's really, really important. Otherwise, you can't tie it back. From this screenshot, for example, that there are some char arrays, some concurrent hash map entries, and some strings, which have got a really high number of generations. Those are the target objects, which are the symptoms or the result of a memory leak that's probably happening. But what you want to do is find out what source code of yours is generating those char arrays, generating those strings, generating those hash map entries. So here's an example where we've recorded the allocation stack trace, down the allocation stack trace until we get to the lovely and method name, which belongs to a tool called Hawkshaw. So it is the Hawkshaw in-threaded managed cache class with the produce key run methods, which is the method which is creating all of these concurrent hash map entries, generations, and is therefore the likely candidate for your memory leak. So that's the source code you want to go look at and fix. A bit of marketing. There's actually a ton of free tooling, as I mentioned before. So if you cannot afford or you cannot get budget for a GC log analyzer, then there are free tools out there like HP JMeter and Visual VM and Beans, as well as Eclipse, MAT, and IntelliJ also has a tool, I believe, can do some of this stuff for you for free. So if it wasn't kernel or system problem, and if it wasn't garbage collection, then we go all, but we are still seeing that the user time, the user CPU time is still high. We then want to have a look at the application code. What is the actual application doing? Really rare, because Java's JIT is so good. It's very rare for a Java program to actually truly bottleneck a CPU. You don't see it all that often, surprisingly. And I'll just give you a very quick example as to how good the JIT is. Here is a tiny subset, the optimizations that are in OpenJDK's hotspot today. Something like 600 or 700 optimizations, if I remember correctly. And they all interact with each other in what I would call mysterious ways for most people. Find out sort of the underlying architecture of how a lot of the stuff works, then person called Cliff Click, and see some of his talks and some of his presentations. So he wrote a fair amount of the original work behind this stuff. One thing that JIT does is it does this thing called method inlining. So basically, I'll use a basic example. If you have class A with a method that is calling a getter or a setter, it's a typical example in class B, and if that getter or setter is called often enough and fulfills some other conditions that the just-in-time compiler says, okay, yes, you are a hot piece of code, you're a piece of code I really need to optimize, then that getter or setter effectively gets brought back into class A, as in you can imagine the source code all getting merged together, which then actually allows the JIT to do even more, to have a wider body of code to look at, to do more things like look at branch prediction, to do things like inline local variables, to hoist constants, to prune out dead codes, a whole bunch of other things. A key thing here, if you're interested in making sure that your code is eligible to be inlined and to be optimized by Hotspot, that methods less than 35 byte codes in size. To see if your method is less than 35 byte codes, you can use the most excellent tool by Chris Newland called JITWatch, and I'll post a link in the notes afterwards to that tool, which will show you a triple view of your Java source code, the byte code, and then the machine code, and it will tell you exactly how many byte codes each of your methods take. You can also use the command line option Java P with the flag -C, pass in the class file, and it will also list all of the methods and the amount of byte codes it takes. All those. Here we have the classic Java enterprisey version of the FizzFuzz tests, and you can see it spans over two slides here. So we've got the main method, we call the FizzFuzz constructor, we've got a couple of getters, a couple of private variables. We have two methods that do the check, so on and so forth. And what the just-in-time compiler will do is it effectively takes all of the source code that you've written, and under the hood it optimizes it down to this. optimizations in this. So one of the key takeaways is that you don't necessarily have to write your code this concisely, or quite often you don't have to prematurely optimize your source code. The just-in-time compiler will actually take care of that for you. It's smarter and can see more things than a human can. So we tend to always advise just trust the just-in-time compiler to optimize your code for you. Just make sure you write your code to good, solid principles and try and keep the bytecode size for your important methods, the ones that you want to execute quickly, bytecodes. Another classic example is what does this code measure? So we've got a start timer, we've got a for loop creating a bunch of new objects, set n to 10 million. So how quickly can we create 10 million objects in Java? So figure out what the average of that object creation time is. And if you run this code, you will get the answer of 0. And I'll leave it up to the Slack channel to discuss as to why that is. But it's a just-in-time compiler doing something clever. If you do need to go in and have a look at what your hot code is, or what code is running less efficiently than you'd like, as well as the JITwatch tool I mentioned previously, you can also use what we call an execution profiler, and that will tell you what Java source code is causing the CPU to be. And again, you can just use free NetBeans tool here. Alt tab you can use, and you basically just say record CPU profile, and you just take a snapshot. It will order it by the thing that's the busiest. A big red bar is bad. And remember, always please remember to record allocation stack trace. If that is an option in some older versions of the profiles, most profiles just do it by default now. Yeah, so only in emergencies attach a profiler to production.
Martin, sorry to interrupt you. It seems that you dropped the connection something. So currently we don't see the screen share. We see your profile picture instead. And if you could repeat maybe the last 20 seconds to half a minute.
Okay, no problem. So I'll just try and screen share again.
Yep, that'd be lovely. At first I thought it's my issue, but it seems that it's your connection.
Let's try this again. Okay. Is that how we back?
Nope. Maybe you can refresh the whole Hangouts browser.
Yep. Try that now quickly.
Quite sorry about this happening, but there is nothing to do against the technical issues. Yep, Martin, we have now your web camera feed. So cool. Yeah, and now we can see your screen.
Cool. Is that working now?
Yeah, we see the slides cool. Now with the code, and we see the NetBeans execution profiler, and we can
Perfect.
see you as well.
Awesome. Okay, so I'll start at the next NetBeans execution profiler again. So quickly, if it is your CPU is user dominant, you know it's not garbage collection, you can then throw what we call an execution profiler at the problem. So you can attach to your running JVM with an execution profiler. NetBeans and Visual VM have free ones. There's also tools like and so on. These profilers will record what source code effectively is driving the CPU to be this busy, and the big red bar is bad. You can have a look at which one of your methods or which few lines of code is causing the CPU burn to occur, and you can make modifications from there. I mentioned JITwatch previously. Here is unfortunately a bit of a low resolution picture, but you can see the Java source code on the left, bytecode in the middle, and machine code on the right. It's a fantastic free tool. And if you're going to do benchmarking, and I was tricking people with the how quickly does it take to make a Java object, then you want to use another free tool called the Java Micro Benchmark Harness by Alexei Shipalev, who Red Hat's JVM performance lead. So if you are going to optimize for the just-in-time compiler, remember it does almost everything for you. Make sure you use tools like JMH and JITwatch to do those optimizations. The last path in the diagram, if you remember, is if the CPU is actually not busy, that means it's idle. It's effectively doing nothing, but your users are still complaining, remember. Is that a response hasn't come back, or the database has gone offline, or you've got a deadlock or a live lock inside your JVM. Those frameworks and reactive frameworks make this type of problem actually occur more often, because it's much easier for a Java developer to make a programmatic error or a coding mistake that causes one of these frameworks to not respond correctly, or to post something to the wrong address, for example. There's a really cool free tool called Wireshark, which you can use to spy on your neighbor's network and Wi-Fi connections, as well as finding out what queries are coming in and out of your application, what ports, protocols, and if they're not SSL, you can even go and read the data raw off the wire there. It is an internal Java JVM threading issue. Here is a nice simplistic diagram of how the thread state model works inside the JVM. I will leave it to the readers to study that at their own leisure. Again, you can rely on freedom here. Grab NetBeans or Visual VM and just click on the look at what my threads are doing link. And as you can see here, this particular HTTP thread pool, most of its time idle, and every once in a while it does a little burst of green, so it's processing an HTTP request, or perhaps processing an HTTP response. See, yellow is wait, green is going heads, and red means it's in some sort of a lock. You can very quickly see what your internal threads are up to, and to see if that is the cause of this idle problem. NetBeans, a thread inspector, you can click on any of these threads and get the exact status. It will also tell you deadlock, so it does deadlock detection on your behalf, and it will tell you which two threads are involved. Threads that will tell you what line of code that is involved in, and you can quickly go fix the deadlock problem. If you want to learn how really to do this stuff efficiently, go and take up one of Dr. Heinz Kibbutz's modern concurrency courses. He's pretty much got the best one around. So you can just use Visual VM or NetBeans. They're perfectly free app profilers. Do impact the running JVM that they're profiling. Remember is that all profilers tend to ask the JVM to bring their threads to a stop, to a safe point, so that the profiler can go get the data it needs. Then cause your JVM to pause some more. And it also means that some of the data the profiler is collecting, when those threads have stopped, really their data when those threads were actually exhibiting the problem. So again, you have to take a little bit of care with these free tools. The summary are the physical ones and the virtual ones, where those data centers are. You want to try and use some time boxing, so have the in and out measurements out of all the points in your system. Please do try and follow a scientific model for diagnosing performance issues. We believe, and this has been borne out in our tooling and in our consulting over the years, that you start with the CPU, ask what the CPU is doing. We went through a bunch of very quick tactical hacks. So if you're looking for system and kernel problems, just use free Linux tools. problems, make sure you're producing that log, load up that log into a free tool or into our JClarity Sensum tool. Code, remember the JIT is better than you are in almost every case. Then you can use an execution profiler and tools like JITwatch and JH to see what that code is doing. If you're selectively idle or waiting, Visual VM or the profiler in order to see if you've got deadlock threads, threads that are waiting, or whether it's some sort of external problem. What we're doing to help at JClarity is we do an awful lot of work on OpenJDK and Java itself. We help run the adoption group for new engineers coming into OpenJDK. We run the serviceability requirements and enhancements for OpenJDK. We have our two tools, Sensum and Illuminate, which do a lot of this performance diagnostic model work for you using machine learning. Really great fun to have built that. Today, who goes to jclarity.com, grab a free trial of Sensum, and if you arrange a Sensum as a Service trial, then you'll get the Sensum desktop tool for free for an entire year. So that's my marketing spiel. And at this point, I will stop and we will take some questions.
Excellent. Excellent. We have almost no time. Thank you, Martin, for this session. I love the practical advices after every small chapter. That's the best way to take in the information for me. So Malaga Jock, do I have a quick question to Martin? As you have, yep. You have the precedence over Slack.
Yep. Sorry. So quick question. You have been warning us about being aware of how measuring time can be important for analyzing performance issues. But on the day-by-day usage and for practicality, how much statistically significant are those differences in time between one machine or another, or because of using a network? So how much do we need to care about that across everything? Thank you.
I'm afraid I did slightly miss that question. So it was something to do with how important is the network time between systems?
No, sorry. Question was that you mentioned that different computers, different systems may measure time differently. So we need to be really aware of how we are doing that, because it can give you really where the results. But in the day-by-day practical work, how much statistically significant is that difference across machines?
Oh, I see. That's a great question. If you are working on a low latency trading system in finance, it matters a lot. Because the amount of time that can change is measured in milliseconds, which will impact. If you have hosts that are geographically distant from each other, then the time clock changes can start to move into seconds, and we've seen even minutes occur. So you'll see applications logging backwards, you'll see GC logs get corrupted. And when you're trying to correlate let's say a user request coming in at 9 o'clock in the evening, it does not match the performance issue, which mysteriously seems to have happened 5 minutes beforehand. Aware of it, but for most applications that are in the same data center, it's not a problem.
Excellent. Thank you so much for the presentation, Martin, and for answering this question. Unfortunately, we don't have much time for other questions. I think we had something in the Slack. So if you are in the Slack, can you take a look at the live session chat? If Martin is not in the Slack, Jonathan, I know that you're watching this. Can you please reach out to Martin on Twitter? I think at Cariana. Just find it. And ask the question online. Or how do you spell your Twitter? That was correct. I think you can just Twitter search for Martin and it will give you the answer. So unfortunately, we are out of time. So thanks again for the session. It was really great to see you, and it was a wonderful session. I enjoyed this a lot. Thank you, Malaga Jock. You are awesome. Thank you, Czech Jock.